Hello students, myself Arvind Negi. Today we will be taking electricity part 2. Now today we will be talking about potential difference. So to understand potential difference, let us consider one example. I took two containers of the same dimensions, means same height, same breadth, and suppose I fill the water up to the same level. So the height of the water filled is up to the same levels. Let us say I connected these two containers with a hollow pipe. So in this case, since the water filled is up to the same height and the containers are of the same size, so being the dimensions the same, the water won't go from A container to the B container or either from B to A. So we can say in this case the water is filled in the same containers up to the same height, and the potential difference, or you can say in case of water, we will say the water pressure exerted in A is equals to the water pressure created in B. So the water won't go here and there. Now if I took the another container as of smaller height and a different dimensions, if I filled it this container with water too, now as you can see the water contained in A is greater than the water contained in B. Okay, so the water will obviously flows from A to B position, right? So the water pressure in this case is higher in comparison to the water pressure contained in B. Similarly, this thing happens in electricity. The flow of current is always considered to be flowing from higher potential to the lower potential. Now what is higher potential and lower potential? Now for a circuit diagram having a cell or a battery with positive and negative terminals and a switch applied to it and a bulb, right? So the positive end or the positive terminal of the battery is considered to be at higher potential and the lower potential will be the negative terminal of the battery. So the current, or you can say the conventional direction of the current, would be from higher potential to the lower potential, means the current flows from positive potential to the lower potential. Now for the potential difference, what is the potential difference? The potential difference is the difference between the potential between higher potential and the lower potential. So it can be calculated for a cell, for a battery, or it can be also calculated between any 2 points between a conductor. Okay, so this is called as potential difference. Now for the units or the formula, we generally write V is equals to W by Q. Q, as I said you earlier, that Q stands for the charge. Charge is measured in coulombs and work stands for W. So work is measured in joules. Now this is the definition of potential difference, that 1 coulomb of charge is being flowing in a conductor, obviously in a conductor, and 1 joule of work being done. So if I say positive, negative are the terminals, so the potential difference in this case would be the charge which has traveled from the negative end. As you know, the conventional charge flow is from negative to positive and the current flows from positive to negative. So when 1 coulomb of charge is flowing from negative terminal until it reaches positive terminal, so there would be 1 volt of work. So volt is the SI unit of potential difference is volt. So volt is the SI unit, work has the SI unit as joule, and Q has the SI unit as Coulomb. So another way of defining the potential difference is 1 volt is equals to 1 joule per unit 1 Coulomb. So another way of defining is when 1 joule of work is being done by 1 Coulomb of charge. So the potential difference would be 1 volts. So volt is the SI unit, and it is named after an Italian physicist named as Alessandro Volta. This is the second topic, Ohm's law. Now Ohm's law, let us see this circuit in which potential is given as capital V and the current flowing from positive terminal to the negative terminal. The conventional flow has been shown here from positive end to negative terminal. This will help the bulb to glow. Okay, so Ohm's law generally suggests the relation between voltage and the current. Okay, so what does it say? It says this: V is proportional to I. So this is the condition which is applicable in Ohm's law at constant temperature. This is the condition for constant temperature. The voltage or the potential difference, we have two names for V. One is the voltage and the other one is potential difference. I stands for the current, right? So the potential difference is directly proportional to the current in the circuit, which is available at constant temperature. What does this symbol means? This means directly proportional. Now what does this mean? This means if V gets increased, suppose the voltage of an electric circuit is getting increased, so I will also get increased. So both of the things will get increased. Or you can say if the voltage is tend to decrease, then current will also decrease. So either of the two, both V and I will increase, or V and I both will decrease. Now for this symbol, as you can see, this is the proportionality sign. So we have an exact formula for this. To avoid this proportionality sign, we used to add one constant which is known as R. Namely, this R is known as resistance of the circuit. Now what is resistance of a circuit? Resistance is generally the hindrance provided by the internal circuit. Okay, you can say the obstruction to the flow of current. Suppose the current is flowing from this side, so the obstruction in between the wires will be known as the resistance. Okay, now we will do one numerical. This one is the Ohm's law, V is equals to I into R. Let us say if I take voltage of the battery as 9 volt, I took a 9 volt battery. Let us say the current flowing in the wires is 2 ampere. So how to calculate the resistance offered? Resistance means the obstruction offered. So we have Ohm's law here, V is equals to I times of R. So now putting the values, remember the SI units, voltage, ampere respectively for potential difference and current. So V is equals to 9 volt and I is equals to 2 ampere. This way you can calculate the resistance of the circuit. So this becomes 4.5. Now the SI unit of resistance is ohm. You can write the symbol as ohm, OHM also. So remember the SI units. So that's all for today. This was Ohm's law. Meet you in next video. Thank you.